I'm a geomicrobiologist. My lab is cave explorers. We do a lot of exploration. I was on a trip that found the third biggest room in the world in a cave in China. And I think science is just being curious. And if you're curious about science, then you're like, I wonder where this cave goes. And so that's what we do.
Hello.
Hi,
How are you?
I'm good. How are you doing?
I'm doing really well. What's your name?
Hazel Barton.
Hazel Martin.
Barton.
Oh, Hazel Barton. All right. Which part of the world are you in, Hazel?
I'm in Akron, Ohio.
Are you in Akron, Ohio? That's where Alcoholics Anonymous began.
It is. Yeah, the church where that started is about 3/4 of a mile from here. Yeah.
Oh, wow.
Yeah, it's really cool. They have a like once a year they have kind of a celebration of that, and on a Saturday everybody is on campus. So you go over to a coffee shop and everybody's over there with their pins and everything, and you get to chat to them and stuff. It's pretty inspiring, really, what a lot of these people have been through.
Absolutely. That's an amazing organization.
Mm-hmm.
I noticed there's an English accent somewhere.
There is. It
Okay.
used to be Bristolian, but it's very hard to be understood in the US with a Bristolian accent.
Okay. So you became American.
Yeah, I have a Midwest accent. I think it's funny because Americans think I'm English and English people think I'm an American. So it's mid-Atlantic now.
Well, there you go. So Hazel, who is Hazel?
So I was going to go to a different office. I just got a new office and it's got nothing in it because I got the key on Monday, and I was going to go there and make it and do the interview there because there's like blank walls behind me. But then I thought that'd be a little bit unfair because you kind of get a gist of what I do based on what's going on behind me, including my dirty jacket that I wear in my lab to keep warm in the winters.
Interesting. Keep going. What do you do in the lab?
So how much do you want me to give away? Do you want to try and figure this out?
Tell me everything and we'll go from there.
Tell you everything. Okay, so I'm a geomicrobiologist, and I have very specific environments that I work in. So geomicrobiology is understanding the interactions between microbes and minerals, and how microbes can change the chemistry of minerals, and in changing them affect their structure, turn them from solid to liquid to solid. And also how microbes can get nutrients and get energy from those minerals, but also how they can liberate products from those minerals. So one of the big things we're working on in the lab right now is how you can take carbon dioxide out of the air and turn it into a carbonate powder. And so it's kind of like a white powder. It's really important. About 40% of the weight of paper is this calcium carbonate powder. And right now it's mined. And it produces a lot of CO2 when you mine it. You have to sinter it, which means heat it up to 1100 degrees centigrade for 24 hours to sinter it, to turn it into a different form that then you can make the powder from to make paper. So 2% of global CO2 emissions come from these carbonates right now, from making carbonates like this. And our microbes can do it passively in the lab. So one of the projects we're working on is trying to figure out how to accelerate that process and start making these an industrial scale without having to do any of those CO2 generating processes.
I'm going to tell you a funny story.
Okay.
When I was at school, I had a chemistry teacher. I'm not going to mention his name, but he wasn't
O-level or A-level?
O-level.
Okay.
He wasn't a very pleasant fellow, but that's a different conversation.
They never are.
They never are.
Yeah, I think chemistry is like at that level is torture.
Yeah. And I just didn't listen to anything that I was ever told about chemistry, biology, physics, or any of it, ever. So I once walked into a chemistry exam and I literally looked at this test and I was like, I am completely screwed because I knew absolutely nothing. And that is not an exaggeration. I knew nothing because I hadn't listened the entire year. And I was sitting in front of this test and I was like, all right, I'm screwed. What am I going to do? So I decided just to like make stuff up, literally. So for the entire test, I made stuff up and I ended up getting 18%, which is a miracle in itself because I had made 18% up and it was right. Yeah. So why am I telling you that story? I'm telling you that story because I didn't really understand anything you said. And that's because I never listened in any science class ever. So can you tell me again, but in like a Leon doesn't understand any chemistry, any physics, any biology. Is this even physics or biology? What is it?
It's biology. It's what we do. But I gotta tell you my chemistry story because I beat you my chemistry story.
Go on.
I had my mock A level for chemistry. I did chemistry, biology, and math for A level. And I have my chemistry mock, and I was super stressed out about my chemistry mock. So I went out drinking the night before, and I was incredibly hungover on top of not being prepared for my chemistry A level. And I got 3% in my mock.
Wow.
And it was so bad. I wonder if I got that 3% for writing my name on it. So I got 3%, and I was the only girl in the entire class, and I got mocked for this super low grade, which probably was historic. And I worked my butt off because I was so like, oh my God, what am I doing with my life? I worked my butt off, and I ended up being the only person passing A-level chemistry from that entire class. So yeah.
Wow.
So I can feel your pain on that. Yeah. I should have made stuff up. I probably would have done better.
Wow.
But I love chemistry now. And I've still got a chemistry book that my granddad gave me on there somewhere. My granddad gave it after that exam. My granddad gave me a chemistry book. And I don't think it's there because I think I gave it to one of the students in my lab, but my granddad wrote, good luck next time, Christmas 1987, granddad, or something in it. So I love chemistry now, and I love chemistry now because it's relevant. And I think when I was taking it at O level and A level, it wasn't relevant. It was just a bunch of facts and figures. And now it's relevant because if I want to do something, I have to know how to manipulate it. And in order to know how to manipulate it, you have to understand it. So I do a lot of chemistry. I would say half of what we do is materials chemistry, because you got to understand how things function on a surface. And it's really a question of a material at that point, as opposed to either biology or chemistry. So my microbes, they live in caves. We study cave environments. And when you live in a cave, you've got to deal with the rock that you are surrounded by, which is calcium carbonate. And for us, it's really safe. If you take Tums, if you have, gastric distress or something like that, you can take Tums and kind of calm all that down. And that's just the CO2, the calcium carbonate in Tums dissolving, and you burp out a bunch of carbon dioxide. So it's completely harmless for us, but calcium is really toxic to microorganisms, and they have a hard time dealing with it because it can get inside the cell and change cell chemistry. So if they're living in a cave where calcium is just a sea around them, they have to get rid of it. And the way they do it is they pull CO2 from the atmosphere and they add it to the calcium and they spit out calcium carbonate. So they make these powders, and we can grow them in the lab making these powders. So it's very kind of passive. You just kind of have it sitting in a test tube and you just let them breathe, and then they precipitate this calcium carbonate. And so my lab, we figured out, and I say my lab, me and my students figured out the whole pathway from like CO2 gas going into the microbe and then coming out as these carbonates. So that's one of the things that we work on. normally, if you're going to make these in the environment, because they're a rock, you've got to turn them into a dirty rock. Like imagine a rock you pick up in your garden. You've got to take that and you've got to turn it into this very, very smooth stuff to make paper. So paper is cellulose from a plant, which you can kind of crush down and make paper, but it's rough and it's not very absorbent. So what you do to make it smooth is you cape these calcium carbonates on top. So you got to make them very small and you got to make them very smooth. And to do that, they take rock from a quarry, dirty rock like you might get in your garden. They heat it up to 1,000 degrees until all the CO2 off gases, and that turns it to this compound called lime or lye. And then they mix that with a harsh chemical, sodium hydroxide, that causes the carbonates to crash out in very fine particles. Then they take those and they make paper. So you're releasing CO2 into the atmosphere when you heat it up, but it gets reabsorbed when you make the paper. But it's the heating to 1,100 degrees and the mining and the quarrying and moving everything around the country that makes it so high in producing CO2. So what we do is we just take that super passive process and just feed the microbes and get them to do it without any of that heating or crushing or anything. And for us, not only do we get rid of the need to heat to 1,000 degrees, but it's taking CO2 out of the air. So we're actually fixing carbon dioxide in the process.
I feel like I
did I lose you again?
You did slightly. I feel like I'm back at school. So I'm going to ask you.
Yeah, no, I'm a professor, so unfortunately, I tend to. My husband yells at me when I lecture him too.
Yeah. So I'm going to ask you a rather bold question. I ask, please don't delete the podcast. Don't leave the meeting. Is that a deal?
Yeah.
Okay. Why should anyone care about what you just told me? I'm sure there are many, many, many very good reasons why they should, but I'm just curious what the answer is. And bear in mind, I'm sorry that I'm doing this to you, but bear in mind you're dealing with someone that understands nothing, and probably everyone who's listening to this, unless they're a genius, understands a little bit more or less than I do. So let's distill it. Why should anyone care?
Because the current process produces several gigatons, so several million tons of CO2 into the atmosphere every year.
Okay. Now
so
we're talking.
We would not release several gigatons of CO2. We would also pull in atmospheric CO2. And if we can scale it, several gigatons of CO2.
Okay, so now I'm understanding it. So you're saying to me that you guys are creating a type of paper,
a powder,
you make paper with that doesn't harm the environment.
Right, and you can put it in paint. You can put it in paint. 20% of paint is made with this material. Plastics, a hard plastic, to make it hard and make it moldable. They put it in plastics. Glues, I don't have anything I can put my hand on that's got a glue in it, but glues are made with these agents. So they make something like 3,000 million tons of this stuff, right? So 3 billion tons of this stuff a year, and all of it releases CO2 into the atmosphere.
So basically, you are a climate warrior.
No,
you're not.
It's one of the things that my bugs do. They do lots of other things.
What other things do they do? And what bugs? What do you mean?
So we explore caves. We go all over the world and pull microbes out of the caves. So have you ever seen a stalagmite or a stalactite in a cave?
Yeah. So yes.
Have you ever wondered how and why they form?
Yes, tell me now. So my brain is on fire. How does it work?
Calcium carbonate. So microbes start the process that forms them.
Okay.
And so
you go into the caves.
Yes.
You look at the microbes.
Yes.
You come out of the caves with the microbes, and you find out ways that the microbes can help humanity.
Yes. Antibiotics, novel antibiotics, understanding antibiotic resistance, figuring out ways of mining important elements without having to do destructive mining. We're trying to understand the limits of photosynthesis for looking at whether there could be life on Mars. We're looking at deep systems in South Dakota to understand how life could have emerged on Europa, which is a moon of Jupiter. So yeah, and it's all just caves. So I there's like lots of different kinds of scientists, and some scientists are kind of like they jump into the pool and then they dive deep and stay down there. I feel like I'm a skip, when you skip a stone across the pool, I just kind of bounce along with all these different ideas, but the central theme is the pool, and that is for us caves. So we go all over the world exploring caves.
This is amazing. You're like a caving chemist.
Caving microbiologist who passed A-level chemistry.
That's amazing. So tell me some of the stories of being in a cave. I tell you what, actually, I'm going to tell you a story.
Yep.
So I went to a cave in a cenote in Mexico.
Which one?
An underwater one in Tulum. And
in Tulum, that was probably Dos Ojos.
I don't know which one it was, but what I remember is going into this cave with a guide, and we went in. He had one light. We went into the furthest reaches of this cave. He turned off the light, and there was total silence and total blackness. And honestly, I sat there for maybe half an hour, and it was a profoundly moving experience for me, being in this cave.
Underwater?
Well, I wasn't underwater. I was swimming above, and then I sat above the water.
I wonder if that's Jaguar Cave. Yeah, so I did a bunch of cave diving in those caves. I did a bunch of exploration in those caves around 98 to 2002.
And what is it like for you? Like, what kind of experience have you had in those caves that have touched you?
Cave diving in those caves is pretty easy. So I have friends who are sump divers, people that, were involved in the Thai cave rescue, things like that. And they're in like really challenging conditions. And the conditions in the cenotes in Mexico, it's like swimming around in gin, right? You can see 300 feet. And the sea level used to be a lot lower. It used to be about 300 feet lower there. And so the caves used to be high and dry. So they've all got stalagmites and stalactites. So normally when I'm traveling through a cave, I'm kind of trying to avoid climbing around the delicate stuff and not touch it and, avoid damaging it. When you're cave diving, you're floating like you're doing a spacewalk, and you just float right through the middle of the cave. You want to go look at something instead of having to climb up there and use bolts and ropes. You just press on your BCD, your buoyancy device, and you just go up and take a look and then dump air and come down. So it really is like floating in space. But to be a really good cave diver, you have to cave dive all the time. And I was a good cave diver back then. I was kind of ballsy and did a lot of big dives, but I wanted to become an academic, and you can't spend the kind of time you need to be safe cave diving and have an academic career. So I haven't been cave diving in about 17 years, but I did a lot down there, a lot of stuff. Before all that got opened up to tourism, we were out there hacking through the woods with machetes, carrying gear into some of the cenotes now you can drive a car up to and take steps down into. We were involved in discovering those entrances from inside the cave, and just popping up in the middle of the jungle and getting a GPS bearing and then diving back in again.
Amazing. You mentioned how you're trying to figure out, by going to these caves, the microbes, whether there's life on Mars. How does going into a cave on Earth determine whether there's life on Mars and Europa?
Yeah, so there's two different chemistries we're looking at there. For Mars, right? So Mars is further away from the sun. And because it's further away from the sun, it doesn't get as much irradiance, so not as much energy gets to it. And you can get some filtering of the light, so you get different wavelengths as well. And we don't have any models for what that would look like on Earth, except for cave entrances. So we did a study in some cave entrances in New Mexico where the cave, you go in and you actually go around corners, right? So, if you're looking from the top down, you go in, it takes a bend, it takes another bend, go back here. So it's complete darkness. You can't see, you do this with your hands, you can't see them. And we found photosynthesis way back there. And it turns out that the rock the cave is made of can reflect in near infrared. So you have light that you and I are seeing each other with right now. That goes up to a wavelength, the size of the photons, the wave that they make, to about 650 nanometers. And then beyond that, you have a range of about 750 to 900 where you get into near infrared. And then beyond that, you get into infrared, which is basically like heat, right? The range of heat. And in that near infrared zone, that's where the rock of the cave actually reflects it. So it's actually reflecting near infrared, which our eyes can't see. Bugs and things can see in those wavelengths, but our eyes can't see. And because it's so reflective, it will actually bounce around the corners of the cave. So complete darkness for us, and we're finding photosynthesis and evidence of photosynthesis. So what we can do is we can go into that cave entrance and be, this point right here has the right light intensity as if we were standing on Mars, or if we were in the entrance to a lava tube on Mars. And you can go in and you say, can life do it? Is it possible for life to live there? The other thing is, because of the wavelengths that get reflected, we can look at different kinds of stars. So instead of our kind of star, the sun, we can look at different types of stars, like an M-type star, which only emits in the infrared. And so we could actually look, could you have photosynthesis of an entire ecosystem on a planet where all the leaves would be black because they're absorbing in near infrared, right? So you could support life that way. So that's Mars. And then for Europa, it's a frozen shell with an ocean underneath. So it's a water world. And we don't know a lot about the chemistry under there, but we know we have a really good idea of what the rocky core of that moon is made of. And we think it's a silicate that might be rich in manganese. And it was never thought that manganese could support an ecosystem, right? You've probably heard of like salt, you've gone to a hot spring and it's super stinky and it smells like eggs. That's because microbes are using sulfur. You may have seen like an acid mine drainage where you have like goobers of red stuff in a stream, and that's iron supporting that community. Well, no one's ever seen that from manganese. We know it's possible. And deep in Wind Cave in South Dakota, several hours of travel from the entrance, you actually get into a lake. And we think that the rock in that lake is feeding the microbes manganese, which would be kind of like a black material. I'm not sure where people would see it naturally in their lives. You have to get it in your diet to survive, but it's supporting an ecosystem. And that could be evidence of the kind of life that we would find in Europa underneath that icy shell.
You are far more than a chemistry teacher. Wow, amazing stuff.
I know, I saw your eyes glazing over there and I was like, yeah.
No, but this is great stuff. I mean, I'm very fascinated with space. I'm very fascinated with like life on other planets. So do you think there is life on other planets?
Oh, yeah. Loads of, whether in our solar system, I'm not sure. I think, yes. The way that life evolved on Earth with such a quick radiation, I wouldn't be surprised if it evolved on Mars and seeded to the Earth, because it was so quick. It was about 200 million years after the planet cooled. And that just seems like a fast window for complex life. I mean, it was microbial, but to form with all the systems it uses. I think, we know that Mars was warm and wet 1 billion years before we were, and it was stable. So I think it's more than likely that life may have emerged on Mars and then been seeded in a meteorite onto Earth. Because we know microbes could survive those. They could survive getting lifted if they were ejected in a certain way. They could survive if they're inside a piece of rock on the cosmic journey, and then they could survive landing on the planet if they're deep enough in that rock. And there's spores from ancient Egypt that are 5,000 years old that you can still culture on a plate. So I think it's entirely likely that that's the case. Now with James Webb and the discoveries of the numbers of galaxies and how many of those galaxies have how many stars are in those galaxies, and that most stars have at least one planet, and a lot of those planets are in the habitable zone. I can't remember what's there's the Drake equation. You do those calculations and like how many planets that can sustain life are out there. Well, every time James Webb gets turned on, that number becomes a lot bigger, because we know there's billions of galaxies with hundreds of billions of stars, and multiply that for planets in them. So yeah, it's out there. I'm really interested in the idea of I think it's called I don't know if it's the Great Roadblock or something, but it's like, why haven't we communicated? Technology should be good enough for us to communicate. And so there's an idea is that there's like, tens of thousands of civilizations that get to our level of advancement, but there's something in the way, right? That all those societies encounter something and no one's figured out a way to get past it, whether it's like the development of weapons and war and competition, or it's climate change, or it's resources. Why haven't we communicated? Or maybe the distances are just so big. So I'm really interested in that idea, is that, because it makes you view life, like our society and the choices we're making, especially when you think about climate change, and like, we're all like freaking out. As a microbiologist, we've been freaking out about corona type emergent diseases since the first SARS was seen in 2003, right? We're like, oh my God, this is a big deal. And no one could care less. And then all of a sudden, everybody cares. So we're kind of like that with climate change. It's like, everybody's freaking out. And this is like 2003 with SARS. It's like, why isn't everybody freaking out? Why do we have to wait another 17 years until we have this, global catastrophe that we could have done something about? So I always wonder, thinking about that idea that there's some hurdle that civilizations have to be able to get over to communicate, whether that's what we're looking at as a society. So, it's a bit contrived to say that, we work on this to solve that problem. We work on it because it's super fun and it's super interesting. And we explore caves all over the world. And it's not just going in and like sampling. My lab is Cave Explorers. We do a lot of exploration. I was on a trip that found the third biggest room in the world in a cave in China. I was, almost 1,000 meters underground in Mexico in spring. My graduate student was more than 1,000 meters underground in Mexico in spring. My other undergraduate was the deepest woman in the world in 2020. We have some really, really good cavers in my lab who are just curious. And I think science is just being curious. And if you're curious about science, then you're like, I wonder where this cave goes. And so that's what we do.
Have you ever watched Tomb Raider?
I have a friend, he's a famous scientist. He said, what's her name? It's, what's the name of the character in Tomb Raider? I
don't know the name. Angelina Jolie played her. Yeah.
He said I'm that. People used to call me the real Indiana Jones. And then he says I'm the real Tomb Raider. So, but I don't steal stuff. I get permits. Everything we do is with the permits. I don't do it. And I've never felt the need to wear a gun. I have had to deal with them on expeditions. When we were in Greenland, we had to carry guns to the toilet because of polar bears. But I never had them kind of strapped on my thighs.
Wow. Well, I'm glad you never had to use it. Did you ever see a polar bear?
Yes. It was a mom with her two babies, and she was teaching them how to hunt. And she grabbed the bird out of the air with her pulled it down and ripped it apart right in front of us, which is when you realize why they make you carry a gun to the toilet.
Yes, because that would end badly for you and for anyone in the crosshairs of a polar bear.
Yeah.
Question about Mars.
Yeah.
Do you think we'll ever find fossils on Mars? Because that would be it. That would be the end, right? The moment you find a fossil that's a real fossil, it's over.
There aren't that many places on Earth where you can find a fossil that old, right? You can find them in Australia. You can find them in Greenland. You have to find a piece of rock that is old enough that it didn't get subducted and melted and spat back up. Mars is a lot more stable. It's core solidified, and so you no longer had tectonic activity and plate dynamics on Mars a very, very long time ago. So you have a much larger area of the planet to sample. I've done some NASA stuff and been an advisor to NASA on like how to look for this, because we look for evidence, very, very tiny amounts of evidence in caves of life. So I've advised them and written papers for them. And it's going to be dumb luck, I think. You've got to know where to look. You've got to know how to look. And you've also got to look in a way that's not dictated by what we know about Earth. Right. So if we go look at it, you can't send a biologist to go look for fossils on Mars, because a biologist is going to know what they look like, and they're not going to look like you imagine they look like. So I think that's the big key, is exactly what evidence do you look for? And I don't think we should look for like a classic fossil. When life does its thing, a lot of times it has to move energy from one place to another. And that movement of energy will create a gradient of chemistry that you can measure even over like millimeter scales. And I think if we find evidence of life, it's much more likely to be like, there's no way that we could have moved this chemistry over here without something pushing it. And that is evidence of life. So I think that's might be what we find. I would love to see the Mars 2020 mission send samples back so we can actually shove them under a microscope. But you can imagine anywhere on Earth, just, collecting a core, sticking it in a tube and shooting it into the space, the chances of, that core having the smoking gun. Carl Sagan said, what was it? Something about dramatic claims require dramatic evidence. And so it's going to be very, very hard. I mean, we can't convince people that global climate is changing, right? So how are we, for a lot of people, it's not about science, right? It's not about evidence and data. It's about dogma and what does it mean? And so I think it's really kind of interesting. I'm not a religious person, but the Catholic Church spends a lot of money looking at how finding life elsewhere would affect scripture and how you would interpret scripture. And it's a very pragmatic way of looking for it, because you don't want new information to threaten people's beliefs. They do need to figure out a way to fit it into their worldview in a way that doesn't feel like a challenge, because if it's a challenge, you're going to reject it. So I think that the Catholic Church is very smart in that. It's like, we have this powerful God who does all these things in ways we don't understand. What would this mean for us? And especially with James Webb, if anything's going to find evidence of some kind of molecule, organic molecule in an atmosphere of a planet that can't be explained inorganically, it's going to be James Webb. So, being prepared for that, I would hate for it to become another moon landing or the Earth is flat, where people it's so challenging to their level of understanding that they choose to reject it rather than celebrate this enormous achievement it would be for mankind to discover that.
How do you think James Webb is going to change our understanding of the universe?
Oh my God. I feel like I'm so naive, and I've done a lot of space science. And so I'm like, I feel like I know 3% of what it's capable of. And that's super exciting to me. So there's a lot of very clever people involved and a lot of very, very good communicators. And it's such a big idea. And, it's a pretty, the way it's set up is anyone can get time on it, right? It's like Hubble. It's very, very difficult to get time on it because it was just Hubble and that's all there was. For this, it's very much democratic. You write a proposal and you need an hour on the James Webb and you have a good idea, you can get an hour on the James Webb, right? So there's all this thought about what it could change based on its capabilities. But then you layer on another level of all these new people coming into the field with a tool and technology to answer questions we didn't even think we knew we could answer. And then what do those questions become? So I'm excited. I'm sure you do too, get nerding out when as soon as you see a release come up, you're like, oh God, what did they find now? So Yeah, I think it's going to make us feel very small and very privileged to know that we've created, like, life is. Sometimes I'm like sitting on a plane flying somewhere, and you got the physics that holds the plane up, and the technology to make the alloys that support the plane, and the technologies to have, you know, your little backseat plane video making, you know, showing you a film with special effects and stuff like that. And just all the technology, you're like, am I a brain in a jar somewhere that I'm just imagining that we could have developed from single cell organisms to this level of technology? Or is it just all make-believe? And so I feel that it's pretty profound how far we've come to be able to put an instrument like that in the universe to understand our place in it. But ultimately, it's going to pull back and make us be like, wow, we are just tiny specks, but we're a very, very important speck. And it would be really, really nice to know what else is out there.
What's the greatest thing it's shown us so far? Like the one greatest thing?
The new one is the number of galaxies in the early universe. So they just, I think they just said that they found some galaxies that were 300 million years after the Big Bang. And there ended up being 10,000 more of them, 10,000 times more of them than they thought there were. So it was a much greater expansion than they originally imagined.
So there's no way there's no life somewhere else.
I don't think so. It can't be that rare. It can, if there was no life on Mars and it started on Earth 200 million years after our planet cooled, then there is life everywhere, because that's too easy. It's too easy for that to happen. If it was a 5 billion year window, then but it's 200 million years. It's too easy. Now, maybe if it was on Mars, you can add another billion to that, you can reduce the number. But the question is like communication, right? How far do you have to come in that technology? But if our universe is, you know, so much bigger, so many more planets, I guess it's distance, right? It's just how do we talk to each other over enormous distances, and how many planets get to the technology level where they can communicate?
Amazing stuff. I mean,
it's all from caves. Just everyone who knows me
in the caves.
Yeah, everyone who knows me is going to watch this thinking I spent the entire time talking about caves, and we
well, you didn't.
It's just fun. Everybody looks up, and I look down.
Well, based on what you're saying, that's where the answers lie, right?
And I feel very privileged because cave exploration is relatively new. The ability to go in these big, deep caves has been dependent on, polymers that allowed us to make ropes that could support us, going in, I think we have 5 miles of rope rigged in this cave in Mexico to get to the bottom, right? It takes 5 days. 5 days of travel to get to the bottom because you're so far from an entrance. And we didn't have the technology to be successfully able to do that 40 years ago, right? So it's relatively new what we can accomplish. And because of that, I'm at the point where no one's ever really looked. So we can go in and it's all these low hanging fruit that we can pick at. And I hope that it launches a field that lots of other people can come in and like maybe stand on the branches that we've built and work up and find new stuff. So I'm really excited, but I also feel incredibly privileged to have come in. It's the golden age of cave exploration on our planet right now. I mean, people are finding enormous caves, enormous systems. We've done a lot of work in Borneo, and it's got the biggest room in the world there. And you could actually fly a jumbo jet in some of those cave entrances. I mean, it's just remarkable. And, we get to go there and play around and see this stuff, right? So we've got travel, we've got technology, we've got batteries that you can take one battery and have 5 days of light. Before you'd have had to take 10 pounds of batteries to support that. So it's the golden age of cave exploration. And my lab is kind of riding the coattails of that and doing the science. So I'm very privileged in being able to do that.
And you seem to love to do what you do, because I can sense.
I do. My husband yells at me because I work so many hours, but it's fun.
So I have one final question for you.
Yeah.
Which, if you can answer this, then you'll make me very happy.
I don't want to make you sad.
No. However you answer it.
Okay.
What is life?
Oh, that's really hard. hard. Yeah. So this is a really hard question. It's hard to define, and this is a big issue for like NASA. Like, what is the definition of life? Because you can have lots of different things that meet the criteria of self-replicating, and they're not alive. So life really is a self-replicating entity that can pass information onto its offspring. And so the reason that we word it that way is that you can have minerals that when they're in a certain environment and they come into contact with another similar chemistry, create another mineral. And so it becomes self-replicating, in which case that's not life. What those minerals can't do is they cannot pass information from one to the other unless that information is just structure, right? So it has to be more than that. And so life itself is basically a self-replicating unit able to pass on the information to make a copy of that self-replicating unit.
What created life?
Chemistry.
What created chemistry?
Physics.
What created physics?
Well, we are in a physical universe, so I would say the Big Bang.
What created the Big Bang?
Oh, now that I don't know. Now, if you're into creator, now I like the whole multiverse thing. I like to think that there's a version of me somewhere that's a movie star.
Well, there's a version that's right here. The caving movie star Tomb Raider.
Yes.
Wow. Well, look, when we first started, I was a little bit like, if we're going to talk about chemistry, then we're screwed, because I have no understanding about chemistry, and I'm sure most people don't. But then when we started to talk about like caves and Europa and Mars and life, and everything started to fall into place.
I feel very, very privileged, very lucky to lead the life I lead, to be able to ask the questions I ask, to be around the people I'm around, to have the friends I have, and to experience caves. And not just go to the caves, but the whole process of the people you meet to get to the caves. So yeah, I can be pretty boring and studious and professorial, and my husband hates being lectured to when I'm explaining something to him. But it's okay. It's me.
No, it was beautiful, and thanks so much for agreeing to do this crazy thing where I have no idea who you are. But by the end of this call, I have a much better idea of who you are, and it was a beautiful conversation. So thanks so much.
Thanks, Leon. It was very interesting. I enjoyed it. Thank you very much.
Hello everyone, it's Leon here, aka the Kindness Guy. If you like my videos, which I hope you do, don't forget to press the subscribe button, and also to ring the little bell so that the notifications notify you that I have a new video out in the world.